Okay, cool. So I think now we are officially live. So welcome back to the latest episode of our Radiance Field podcast slash live stream. So today we have a really special guest. We have Yoshiharu Sato of Gauzilla Pro, and we're very excited to talk about some of the things that Yoshi has been building for the last year. So I think we can just kind of get right into it and just talk about, give us an intro about like who you are and what kind of prompted your journey with Gauzilla.
Yeah, thanks a lot, Michael, for the intro, and thanks, Janusz, for the invitation. I'm Yoshi Sato, the founder of Water Technologies, which has been developing Gauzilla Pro, which is an AI-powered and no-code web editor for 3D Gaussian splatting. Well, I guess I have somewhat unusual background because I kind of made a full circle starting from 3D engine development and moving on to apply machine learning and AI to financial trading in finance, and then coming back to 3D for radiance fields and 3D Gaussian splatting. So as I mentioned, in the past decade almost, I worked in the financial industry, applying AI and machine learning to trading strategies at hedge funds and trading firms. But I have a original background in real-time 3D graphics programming. I loved playing 3D games as a kid on consoles, PCs, GoldenEye, Nintendo 64, or Counter-Strike on Windows 95, 98. So I started 3D graphics programming because I wanted to make 3D games myself. And so I developed a 3D engine myself when I was in high school. Back in early 2000s, and I wrote the engine using OpenGL and in C language, later in C++, and showcased the tech demo at the Game Developers Conference, GDC 2005, in association with a company called Graphic Gravity, which was developing a OpenGL API debugger at the time. And in hindsight, I guess I was a very good customer for NVIDIA because the GeForce 2 MX, GeForce 4 Ti, GeForce 6800s and GeForce 8800 and so on. So so nowadays, I guess more than 80% of revenues in NVIDIA come from data centers. But I guess back then, most of the revenues were for consumers. So I guess I was a very good NVIDIA customer back then. But anyway, in 2006. I got invited to work at Crytek, which is a game developer in Frankfurt, Germany. But I couldn't join because back then I was just a teenager and I didn't even have a bachelor's degree, so I couldn't move to Germany. In late 2007, they released Crysis, the PC game. And so I was very blown away by its high quality graphics. And so much so that I decided to actually quit their development of my 3D engine because it was no match for a young programmer like me to compete in this in the field. So and of course from the technology standpoint, I think Crytek did almost everything at the time, mostly like dynamic lighting and shadowing on large scale outdoor environments, or terrains, or dynamic refractions on dynamic water surfaces, or smooth and natural character animation, using inverse kinematics. So basically, I felt like real-time 3D graphics was essentially done, and I wanted to try something new in graphics. And what I started was I started developing a 3D voxel engine. So voxels were not extensively used at the time because GPUs back then were mostly optimized for the rasterization of triangles and the programmable shaders executed on them. So but there was this very impressive software-based voxel engine called VoxLab. It was developed by a programmer named Ken Silverman, who is the author of the Build game engine back in 1990s. And so this VoxLab engine, it allowed fully interactive voxel environment where you scalp surfaces or destroy objects really in the scene. and the voxel volumes were compressed with the very smart RLE compression, or round length encoding. And in 2008, there was this new technology, voxel technology called sparse voxel auxiliary, or SVO. It was a very complex representation of high resolution voxel volumes. So you could essentially stream out voxels on the fly as necessary. And it was demonstrated by John Orlick at its software at SIGGRAPH 2008. So I continued the research and development of voxel engines for some time. But actually, I came to the conclusion that maybe voxels will not replace triangles because it's highly inefficient because of the pixel to surface backward rendering, like ray casting or ray matching. Nowadays, there are many voxel-based games like Teardown, which has a very realistic physics engine, and most recently Doom 2 Race Race, which features a real-time path tracing of voxel objects. But still, these the objects in this game look very blocky, just like Minecraft-style graphics. Although Minecraft itself does not use any voxels. So around 2009, my primary interest has shifted to financial trading, not only because I thought real-time 3D graphics was essentially down, but also during the great financial crisis in 2008, somebody made a 100x return from options trading. So somebody bought a bunch of put options on the Nikkei index futures options. So when the global stock markets collapsed in September 2008, those deep out of money options became very valuable. So somebody made a lot of money. So I am very fascinated by such extreme convexity or upside risk. So eventually I got degrees in finance, quantitative finance, did research on HFT, high frequency trading, with the ultra low latency programming in C++, and worked in the industry in the past decade almost, hedge funds and trading firms, apply AI and machine learning. Then NERF came out, 2020, the original paper by, Ben Mendenhall, UC Berkeley, in 2020. So in the same year, 2020, another NERF paper came out, which was titled, Neural Sparse Voxel Field, or NSVF. And it utilizes the sparse voxel auxiliary for the acceleration of NERF. And so it was 12 years after the invention of the SVO. So I was very impressed, and it revived my interest in 3D graphics. So and there was also other applications of voxels to NERF, such as pronoxels, which is a radiance field without using our neural networks. It used sparse voxel grids instead for as an explicit primitives for the radiance field. Also, there was instant NGP, which used voxel hashing for the acceleration of NERF. So those series of advancements in NERF really revived my interest in 3D graphics. And last year, 2023, our 3D GS, 3D Gaussian Splatting came out, which is truly groundbreaking in many aspects, in many ways. So so I started working on 3D Gaussian Splatting, and that's how I ended up being here, I guess.
Cool. That's a long history, right? But it's interesting that you find your passion, you come back to your passion. So I would be interested, what made you start your current company and the Gauzilla project?
Yes, so my company, Volvic Technologies, which is a very, very new startup. I just founded the company back in April this year. And the company has been developing Gauzilla Pro, which, as I mentioned briefly earlier, it's a fully web-based, no-code and AI-powered 3D editor and viewer. So the system is written in Rust, which is our thread-safe and memory-safe language. It's very famous for high execution performance, comparable to C and C++. And Gauzilla runs in WASM, or WebAssembly, which is a platform agnostic, safe, sandbox environment in a web browser. Also, it utilizes WebGL2 for high performance, highly compatible GPU accelerated 3D rendering in the web browser. Also, it features serverless and GPU-less Vision AI as a WASM module for dynamic object segmentation, annotation, and 3D Gaussian scenes. So the main reason why I started this Gauzilla is because back in late 2023, last year, there was almost no 3D Gaussian splatting editor. There was this maybe only SuperSplat, which is an open source 3D Gaussian editor. But back then, the functionalities and features of SuperSplat was limited. So I thought that there should be some 3D Gaussian editors for commercial purposes or for professional. So that's why I decided to develop Gauzilla Pro.
Cool. And by the way, how did you come up with the name Gauzilla?
So Gauzilla, it's kind of a combination between Gaussian and Mozilla, because my company is not associated with Mozilla, the developer of the Firefox web browser, but Mozilla has been very active in supporting the development of the Rust programming language, as well as the WASM WebAssembly platform. So it's kind of a combination of Gaussian and Zero.
Nice. And so, one of the questions I want to talk a little bit more about are some of these like applications in which, Gauzilla Pro like really like shines, because I think we'll get into some of them a bit more, but, I think that there's some really strong and compelling uses for this.
Yeah, so there are several industries or sectors that are already utilizing 3D Gaussian splatting. So, for instance, in the fields of PropTech, AEC, architecture, engineering, construction, or BIM, building information modeling. So 3D Gaussian splatting has been utilized for capturing, recording. As you can see on the screen. So companies in those fields are utilizing 3D Gaussian splatting for capturing, recording, monitoring, and analyzing the progression of construction projects by generating 3D Gaussian reconstructions from drone footage. And so on Gauzilla Pro, you can visualize a 4D time lapse of those construction projects. I think which is very convenient for construction companies, real estate developers, and other stakeholders to monitor and analyze the progression of their construction projects. For analyzing the construction processes and maintenance processes for more optimization of those processes. And so in terms of 4D time lapse, so there's already this technology called 4DGS in the academia, which utilizes neural networks to predict the movement of individual 3D Gaussians over time. But this technology is not necessarily ideal for slow-paced dynamic scenes, such as those construction sites. Because, for instance, for faster paced dynamics, such as people playing sports, for instance, it would make sense to capture a 360 video with a synchronized cameras, because the time frame, the changes in those dynamic scenes take place in those time frames of those synchronized videos. But for slow-paced dynamic scenes, such as the construction sites, the changes in the scene are actually very small. Because, for instance, if you fly multiple drones at the same time in 30 minutes or 45 minutes in those short time frame, then the actual change in the building, in the construction site, is very minuscule. Mm-hmm. So so 4DGS is not necessarily able to visualize the dynamic intertemporal changes of those types of changes in the scene. And of course, for slow-paced dynamics, such as construction sites, there are strong variations in colors and geometries. So, for instance, in the case of construction sites, there could be a lot of differences in weather conditions, lighting conditions, and there could also be a lot of differences in geometries. For instance, there could be a lot of changes in the traffic on the roads or streets, for instance. So so those are all those are actually an adverse condition for the GS because yes, a constant number of 3D Gaussians. So the way it works is that initially there's a constant number of 3D Gaussians, and a neural network predicts the movement of each 3D Gaussians over time. So if there are many variations in 3D Gaussians over time, it could have many issues in accurately predicting those movements of Gaussians. So so on Gauzilla Pro, it achieves 4D time-lapse by simply concatenating or stacking static 3D Gaussians, and visualizing those changes in the scene by linearly interpolating between those models, which works pretty good actually. It's very simple, but it works. But one unique challenge to that is that you would need to align 3D Gaussians in order to accurately represent the changes over time. So what I'm trying to implement to Gauzilla Pro as some automated 3D Gaussian alignments or registration. So as you know, 3D Gaussians have its mean or central points. So it could be kind of handled or manipulated as point clouds. And there are many point clouds registration and alignment techniques such as ICP or Ransack. And Gauzilla Pro already implements some of these very rudimentary alignment techniques, but it doesn't necessarily work for 3D Gaussians. So it requires more research and development for these automated alignments of 3D Gaussians.
This is a pretty cool use case, I think. How did you come up with it? Is it something someone requested? Because I mean, it's not very obvious to use it for this purpose, and it's very compelling. I mean, if you see it and you see something like a construction building growing over time, and you can represent it with Gaussian splatting, it's really nice. Even if you see the changes in the during the year, from summer to autumn and so on, it's pretty cool. So yeah, my question is basically, is it something you come up with, or how do you get the ideas for your features? Because you have many features which you don't see commonly in other editors, I would say. And so what is your inspiration?
Yeah, so I created a waiting list for Gauzilla Pro a few months ago, and there are 200 plus companies and businesses registered on the waiting list. And one of the companies is what's called Scander, which is actually one of the partner companies of mine. And they are a premier construction company in Chicago. So they have various construction projects in downtown Chicago. And so they are already they've been already utilizing 3D Gaussians for some time. So this this scene that you're showing as one of their construction projects in downtown Chicago. So they've been utilizing 3D Gaussians for the reconstruction of their construction sites using DJI drone, Maverick drone footage, in order to capture and reconstruct those construction sites using 3D Gaussians. And so I was discussing with one of the technologists at the company, and one of the unique ideas that we came up with was this for the time-lapse feature on Gauzilla Pro, because they already had a series of static 3D Gaussians which was captured on a weekly basis. So I thought it would be actually very easy to visualize all those for the time-lapse using 3D Gaussians on Gauzilla Pro.
Yeah, and Ironically, actually, I just was meeting with Ben from Skender just about an hour ago. So we're both here at the Commercial UAV Expo out in Las Vegas. And one of the things that we've seen a lot of at this conference is there's just an overwhelming amount of photogrammetry being used in these industries like AEC. And one of the things I wanted to see if we could briefly discuss is like what are some of the differences between radiance fields. For instance, like we're talking about like Gaussian splatting, which is a form of a radiance field. But what are some of the differences between these two technologies, radiance fields and photogrammetry?
Yeah, so they are both 3D reconstruction technologies in general. And in fact, they have the common pre-processing step, which is the SFM, structure for motion for initial geometry assessments or estimation. So in photogrammetry, you would use MVS, multi-view stereo, for the generation of textured meshes. And in 3D Gaussians, you would use SFM, structure for motion, for the initial point cloud priors to estimate the initial geometric structures. And then you would use machine learning to generate 3D Gaussian sets. But they are very similar. I guess the main differences are in the way in which they render primitives or types of materials that they can visualize. For instance, in photogrammetry, you were not able to visualize transparent objects or reflective or refractive objects, such as window glasses or something like this. In 3D Gaussian splatting, on the contrast, it can visualize a much more wider varieties of materials, such as as I mentioned, those glassy objects or transparent objects, or it can even visualize like fuzzy, soft objects like hairs or furs on the animals. So but basically, they have the same pre-processing step, which is the estimation of geometric structure from the input series of 2D images.
Nice. That's very helpful. Thank you. And so one of the other industries that I want to kind of chat through about it, one of my favorite features of Gauzilla Pro, for instance, is the ability to segment out and really actually like interact with the scene. Because not only do you have this hyperreal visualization of a given space, but you can actually go through, you can interact with things, and you can segment things and kind of like implement more information about everything that's contained inside of there. So one of my questions, I guess, for you is that, like, is this actually something that is just real? Is this like just generalized like science fiction, or how do you implement something like this?
Yeah, so Gauzilla Pro already offers this AI-powered dynamic object segmentation feature, which is implemented as a WebAssembly module, which means that this AI model runs entirely on the web browser. On the CPUs, so it doesn't use any GPUs. It's very GPU Pro friendly, and as you can see on this video, you can segment individual objects in the scene, which is very convenient because by default 3D Gaussians are static, and it's just a set of monolithic set of 3D Gaussians. And for actual applications in e-commerce, for instance, you need to be able to segment individual products or items are on display. So one of the very, I guess, promising applications of 3D Gaussians is e-commerce, where users can, or retailers and businesses can generate high fidelity, high quality 3D digital twin of the entire boutique or store that are by simply capturing their stores using a smartphone. And so they can generate 3D Gaussians on the cloud or on the local machine using solutions like PostShot. And then they can export the scene as the PLY file, which you can import to Gauzilla, and you can segment those individual objects on the scene. So I think those features, dynamic segmentation annotation, are very, very useful for actual applications like e-commerce.
So I guess one question, I guess you don't offer any training, right? So it's currently an editor without the training pipeline, and you need to reconstruct the scene with some other software like Nerve Studio, I guess, or Luma or PostShots or something like this, right?
Yeah, so currently, Gauzilla Pro is only for 3D Gaussian editing. It doesn't offer any 3D Gaussian terrain or generation solutions. And yeah, the main reason is that as you just briefly mentioned, there are so many other solutions for this purpose, like Nav Studio's GSpread, which is open source, or you can use Luma, which is a kind of cloud-based 3D Gaussian generation platform. And there's Polycam, Scaniverse, which is a edge device, edge-based 3D Gaussian generation app. And there are all kinds of apps and solutions already for 3D Gaussian generations. But as I mentioned earlier, there were almost no. So 3D Gaussian editors were almost non-existent back when I decided to develop Gauzilla Pro. So that's why Gauzilla Pro is currently specifically focusing on the editing of 3D Gaussians.
And some of the things I wanted to chat through a bit more too is on, like, say if you are like a retailer and you want to be making a more immersive experience, like this example here. What are some of the examples or things that you could embed, for instance, like individual SKU numbers, or what are some of the other things that people who see this technology and think it's like amazing, like how else do you think it could benefit them from a retail standpoint?
Yeah, so you can essentially display almost any kind of information attached to the products, whether it be the price, or the return policy, or the number of inventories. But since Gauzilla Pro is written in Rust and targeted at the WebAssembly platform running on the web browser, you can actually use almost any kind of JavaScript API to ingest, for instance, real-time IoT data directly into the Gauzilla Pro. I think which is very convenient for applications like e-commerce, because you can, as a retailer business, you can display more varieties of information and knowledge as an interactive annotation on Gauzilla Pro. So, yeah, so these features are, I believe, highly convenient for these kinds of applications.
Can you maybe explain what kind of tools you have to clean up the splat? Do you have like a variety of tools, or just one tool, or what is the workflow?
Yeah, so as you may know, so Gaussian splatting can be sometimes filled with those noisy floaters. Those are the result of noisy input data from the 3D Gaussian training. And you can eliminate or erase those floaters on Gauzilla Pro using this splat selector feature, where you can see a sphere centered at the mouse cursor position. And you can freely adjust its radius, its distance from the camera. And you can select arbitrary 3D Gaussians on the scene. So you can delete, you can select, delete, or copy freely a arbitrary number of 3D Gaussians on the scene. And also you can use the previous object segmentation feature of Gauzilla to remove or clone or move those segmented objects in the scene. So yeah, it can also be utilized for the noise or floater removal as well.
Is the selection tool purely based on the depth or the distance from the camera, because it looks very compelling? Like you are selecting something and like the entire point clutter is selected. Do you use some segmentation in the background for objects?
Yeah, so this the splat feature, where you can select splats using the sphere. It doesn't use any kind of machine learning, so it utilizes some kind of spatial structure in order to quickly identify which splats are inside the sphere. So it's very fast. It can of course it can run inside the web browser without a powerful GPU. So yeah, it's very fast and very convenient.
Okay, so there's no segmentation, so that it detects automatically objects.
No, yeah. So yeah, Splat Selector doesn't use any segmentation. Yeah, again, yeah. As I mentioned, it automatically detects which sprats are inside this sector sphere.
Okay. So,
Nice.
okay, go ahead, Mike.
Yeah, so I was gonna say, so depending on then your use case, for instance, if you are a store owner, for instance, and you wanted to just like see theoretically what something would look like if you rearrange it, that'd be something you could just quickly select, then kind of like drag around in the space. Or if you're an example on the construction site and you just want to move the crane somewhere else or see if the crane will fit somewhere, you could select that and then just kind of like bring it to another place on the location without actually physically needing to move such a large object, right?
Exactly, yeah. So you can freely move those objects around in the scene, which I think is very convenient also for AI and robotics, because for AI and robotics training, you will have to prepare or generate a number of different varieties of simulation environments, which are very costly to generate or create in the real world. But using 3D Gaussians in virtual worlds, it's very cost effective for generating those kinds of simulation environments. And I think Gauzilla Pro can be utilized for generating those kinds of simulation environments for AI and robotics. That's very low cost. So yeah, I think AI and robotics, excuse me, can be also a big potential use case for 3D Gaussians.
Is there currently a known like max capture size right now that Gauzilla will work with? Like if you had a full construction site or just a larger area of land, is there a cap right now?
Yeah, so with regards to the system limit, since Gauzilla Pro runs as a WASM, which is a 32-bit WebAssembly binary execution environment, there is actually a 4 gigabytes memory limit. As to the size of the file you can load from the WebAssembly. So yeah, so 4 gigabytes of spreads. Well, I think it's pretty big. I think it would be almost like maybe 5 million, 10 million spreads in scene. So I think it's very large enough at this point. But in the future, I'm hoping to implement some kind of real-time adaptive streaming of 3D Gaussians directly from your machine, so that you could visualize those large-scale 3D Gaussians by streaming out 3D Gaussians on the fly. So yeah, that's one features that I'm hoping to implement on Gauzilla Pro.
Yeah, I saw there's someone doing already streaming large-scale scenes, and also I think there was like a paper a couple of days ago which also had in concept how to stream scenes. So I think this is something which will come pretty soon in many applications, and it's very exciting because then you can just not only make time lapses from your out area from the outside, right? You could also do time lapses from the inside if you have all the data. Would be very cool. What are other features maybe you want to push in the next time, or what are your plans? In what direction do you want to have this tool going?
Yeah, so there are several other new features that's in the development pipeline of Gauzilla Pro, one of which is dynamic relighting and reshadowing of 3D Gaussians. Because currently, as you know, 3D Gaussians are static. Everything is static. The lighting, geometry, everything is static. And so dynamic relighting will be very crucial, especially for fusing imported objects, like imported 3D Gaussian objects from another scene, or imported textured polygon into 3D Gaussian scene. Because many companies, many businesses already have existing 3D assets as textured meshes, textured polygons. And it will be very convenient for them to be able to import those assets into the 3D Gaussians. So yeah, but the problem will be that there will be discrepancies in the lighting and shadowing conditions, because again, 3D Gaussians are all static in lighting. So yeah, it will be necessary to be able to dynamically relighting and reshadowing 3D Gaussians in order to fuse with imported other 3D Gaussians or textured polygons. So yeah, and so in terms of shadowing and lighting, I guess the degree of kind of sophistication of 3D Gaussian is kind of very low because it's all baked lighting and shadowing. Which is almost like Quake 2 era 1990s light maps, right? But nowadays, So if you look at all the latest game engine like Unreal Engine 5, you can use Lumen, which is a real-time global illumination with all the beautiful color grading and everything. So I think there's a huge gap, to be honest, with the latest polygon-based game engine and 3D Gaussian when it comes to lighting and shadowing.
Okay, so lighting is one feature. Do you have another thing in the queue?
So I was saying that in order to implement those kinds of dynamic lighting and shadowing, you would actually need to estimate surface normals of 3D Gaussians. Because again, 3D Gaussians don't have explicit surfaces. They are explicit rendering parameters, 3D Gaussian ellipsoids, but they don't have surface normals by default. So there are several new academic researchers that try to estimate surface normals from the 3D Gaussian, like RADGS or 2DGS. So those are new techniques allow you to estimate surface normals from 3D Gaussians, which is very convenient for dynamic relighting and reshadowing of 3D Gaussians. Also, there is this very new research paper. I think it's called BIGS, bidirectional Gaussian primitives, which utilizes bidirectional spherical harmonics (SH), and does not require any surface normal estimation. And so if you look at the paper, the quality of relighting and reshadowing is very impressive. Although it requires a special kinds of input data, as well as optimization, lengthy optimization on the GPU. So maybe it's not necessarily practical in order to run on the web browser, but still very impressive research nonetheless. But to be honest, on Gauzilla Pro, at least in the current version, it doesn't support the visualization of spherical harmonics because spherical harmonics, it's great for indirect lighting, via these probes. But according to the original paper by Inria, the 3D Gaussian original authors, the spherical harmonics only contributes to the improvement of PSNR only by 0.5 points, which is pretty low. Since spherical harmonics are not precise, they are very low frequency by default or by nature, compared to, for instance, cube maps. Spherical harmonics are very soft or not very precise. So in the current version of Gauzilla Pro, it doesn't visualize additional degrees of spherical harmonics for view-dependent reflection or those surfaces. But in the future, I might be able to implement those visualization with spherical harmonics. But of course, it's not memory efficient necessarily. As you know, level 2 spherical harmonics requires 9 coefficients for each RGB channel, which is 27 additional coefficients. So it's very memory inefficient. So in the current version of Gauzilla Pro, it doesn't support the visualization of spherical harmonics.
It might be also not very necessary for every application or use case. Do you try to cope something like with baked-in shadows? Because if you are somewhere on a sunny day and there's something standing, like a pole or something, and then the sun is coming from one side, you will see a shadow on the ground. Do you also plan to remove such artifacts which are coming from outside light, or is this not on your agenda?
Yeah, so baking shadows, might be easier than dynamic lighting and shadowing because again, you will need to, you will need accurate surface or number estimations for for these kinds of dynamic relighting and reshadowing in 3D actions. Um, but baking shadows on 3D actions, I think, it's more simpler, I guess. Yeah, because you could do it like casting rays and compute the radiance on the each surface of the each point of the 3D actions. So it's more like traditional radiosity or light maps. My hope is to implement dynamic real-time relighting and reshadowing to the 3D actions. So, yeah.
So now that we kind of gone through that, we've spoken a bit about the long-awaited closed beta of Gauzilla Pro, which it sounds like it is nearly here. And so one of the questions that I had is, when do you think that might start to roll out to select people?
Yeah, so the very first closed beta of Gauzilla Pro will be available to those who are registered on the waiting list of Gauzilla Pro. If you are already registered, you must have received a newsletter where you can register yourself for this closed beta, which begins in late this month, late September. And so I'm hoping to collect and receive feedback from these other users. And based on these feedbacks, I will fix all the bugs and issues. And I'm hoping to implement new features. Then I'm hoping to release the first public beta of Gauzilla Pro, maybe in I don't know, maybe November, December, something like that. Yeah.
What's your timeline? So when you plan to release the first 1.0 version, the official one?
So the very first closed beta, again, it will be released in late this month, late September. Then, I'm hoping to release the first public beta in November, December-ish. Version 1.0, to be honest, at this point, I don't have the exact roadmap. Because currently I'm developing it myself only as a sole developer. I'm trying to expand my team in the near future, over the next 6 months or so. So hopefully I should be able to accelerate the product delivery development over the next this 6 months period. So I would just say please stay tuned for the official release of the Gauzilla Pro.
So you are the only developer. So you're working basically from your living room. Where is your office located?
Oh yeah, so my company is actually based in Estonia, which is a very small country in the Baltics. But country is very cool because the government is essentially all digitized. Because you can apply for this e-residency, which allows you to do almost any kind of government paperwork online using digital signature. So Estonia, since it's a very small country and due to its geographical or geopolitical risk, next to in some big country, so the government has been pushing this digitization agenda in order to mitigate the geopolitical risk. So they've been distributed all kinds of government servers across the embassies in each of the country. So as an American, as a Swiss, you can apply for this e-residency to Estonia, and you can receive this this digital card where you can sign digital signatures on government documents, where you can open corporations, bank accounts, everything. So it's very convenient as to set up a company in the country.
Okay, so you are currently in a seed founding stage, or to get some resources to also get some employees, or what's the current state of the company? Also completely self-financed.
Yes, so my company has just been accepted by one of the world's largest pre-seed VCs or accelerators here in Europe. well, the VC is very global, but the specific accelerator program takes place here in Berlin, which I'm currently staying right now. So the company is in pre-seed stage at this point. So I'm hoping to raise more capital to be able to expand the team by hiring more founding engineers like machine learning engineers, 3D engineers, and front end or full stack engineers to accelerate the product development of Gauzilla Pro in the future. Yeah.
Okay, exciting. Yeah.
And so I also want to quickly chat about the other side of Gauzilla Pro, which is just Gauzilla, which to what I understand is a open sourced facet of Gauzilla. So I wanted to see if we could kind of chat quickly about like the difference between Gauzilla and Gauzilla Pro and how people could contribute to it.
Yes, so there's essentially two types or two versions of Gauzilla. As you mentioned, there's Gauzilla Pro, there's Gauzilla Basic. Gauzilla Basic is an open source, free to use Gaussian scripting viewer on the web. So it's licensed under the MIT, so you can use it for any purposes, including commercial purposes, for free. And what Gauzilla Basic allows you to do is to essentially stream or download 3D Gaussian files from some URL. Then you can visualize 3D Gaussian models on the web. Again, Gauzilla is written in the Rust language, which is very fast, high performance, and and also it runs inside the WebAssembly, which is a very high performance execution environment in the web browser. So I would say that if you're interested in how Gauzilla works, basically, I would highly recommend looking into the code base. Better yet, if you can write Rust code, then feel free to submit PRs. Then I will be happy to review and accept your PRs. And Gauzilla Pro, it's closed source, but it would offer more varieties of features, capabilities, like the AI-powered 3D Gaussian object segmentation annotation that I mentioned earlier, or more features that will come in the near future. So
you're not working anymore on the open source project. You don't push any features, or sometimes, or is it also vice versa that you take? I don't know. Is this an active project?
Yeah, to be honest, Gauzilla Basic is no longer an active project. Although I do maintain the project sometime. Yeah, but the frequency of updates is very, very low at this point, I have to say. So if you want to experience the latest features of Gauzilla, then please sign up for Gauzilla Pro.
Okay, so from your experience, because you're talking to all these people who are on the list, are interested in use cases or are using the software in business workflows, where do you see the main applications, or where do you see maybe some unexpected use cases? If you can share anything about it.
Oh yeah, so again, as I mentioned earlier, there are already several sectors or industries that are already utilizing 3D Gaussians, like AEC, architecture, engineering, construction. So again, as I mentioned, the Scander, the Chicago-based construction company, which has been utilizing 3D Gaussians for the visualization and analysis of the progression of the construction projects in downtown Chicago. Also, there's another Chicago-based construction company or construction visualization company called Helios Vision. They've been also utilizing 3D Gaussians for the visualization of construction projects in downtown Chicago. There are also some other companies here in Europe for the visualization of construction projects using 3D Gaussians. By taking drone footage using DJI drones, DJI Mini, Maverick. Also for in the e-commerce or retail sectors. Again, it has a very great potential. I guess there are not many users or companies utilizing 3D Gaussian yet in this field. But for instance, Nissan, Japanese car makers, car manufacturer. They have recently produced this 3D digital twin of their car dealer in Japan using X-grade LiDAR scanners for 3D action generation. So so X-grade, it's one of the one of my partner companies, and they've been developing this handheld LiDAR scanners for accurate 3D measurements or 3D point cloud measurements for 3D actions. Because as you know, one of the disadvantages of 3D actions is the use of code map or SFM, which requires which estimates the initial point cloud priors from a series of 2D images. SFM often fails at accurately estimating point cloud structures or geometric structures if there is not a sufficient degree of complexity in the color variations of texture details, like high frequency details on those textures. So, for instance, if you're trying to capture a point clouds in an indoor environment with all these plain color walls or ceilings, plain white ceilings like you see in my background, then SFM code map often fails at accurately estimating those 3D structures because they lack geometric or texture details. So that's one big disadvantage of using or depending on code map or SFM. And so in order to overcome these issues, you need to use LiDARs for accurate measurements of geometric structures in scene. So X-rays again, they developed handheld LiDAR scanners for more accurate measurements of geometric structures in the area they want to capture. And you can use their data as an initial point cloud priors to train 3D Gaussians with it. So
so we have a question from Sean on YouTube. Or sorry, did you have a follow-up question, Janusz?
I just wanted to mention, I think this is somewhat similar to what Scanniverse is doing. They for sure utilizing the iPhone LiDAR to make the scans. So SFM has some disadvantages, but there are currently some very exciting progresses in this area, like the Duster master approaches and all the follow-up work. So I think we will also see very soon huge improvements and also in speed.
Yeah, speaking of iPhone, I guess Scanniverse is the only app that runs that runs on the iPhone for the on the edge 3D Gaussian generations, because in the app allows you to generate 3D Gaussians on the device rather than generate it on the cloud. But I don't think the app utilizes the LiDARs in the phone, the iPhone. So but I guess maybe in the future they will implement or they will utilize the LiDARs in the phone for more accurate measurements for 3D Gaussians. But I don't know.
Yeah, we don't know.
So we had a question about how do you balance, making Gauzilla Pro more accessible to like non-technical users to understand like what's actually possible with it versus also comparatively showcasing to developers how to like build on top of it and continue to scale up functionalities.
Yeah, so Gauzilla Pro, it's fully no-code editor, so you don't have to know all the programming languages like Rust or JavaScript. So everything can be done just by clicking on the UI or just typing some text on the UI. So so again, it's a fully no-code web-based editor. You don't have to install anything So again, so if the app is like desktop applications, then most often you would have to install Python dependencies or different versions of CUDA, which is very hassling to say the least. But Gauzilla Pro, since it's fully web-based, you don't have to install anything. Everything is you can run everything on the web, and there's no need to install any hassling Python dependencies or anything. So
Nice. And we got one other question as well, which we spoke a little bit about some of the caps on large scale reconstruction. But I'm just like curious to see your thoughts on some of the other state of the research, like the hierarchical Gaussians or NeurFXL, for instance.
Yeah. So yeah, in terms of large scale, rendering in 3D Gaussians, yeah, as you mentioned, there's hierarchical 3D Gaussians, which utilizes hierarchical tree structures where the leaf nodes are the original 3D Gaussians, and each intermediate nodes are kind of a fusion between those child nodes. So yeah, which is why it allows this the rendering of vast areas of 3D Gaussians. And there's also other, research projects that allows for large scale 3D Gaussian rendering. I forget the exact names. But there are several research projects that utilize this kind of a level of detail structures for 3D Gaussians. Because again, level of details, or LOD, which is a traditional technique in 3D graphics to render objects in a distance. And there are already several projects that utilize this this technique, level of detail, into 3D Gaussians, allowing for large scale interactive visualization of the 3D Gaussian scenes. So for instance, I remember that there is also Octree GS, which utilizes Octree for the accelerated traversal of 3D Gaussian geometric structures. But I guess this is not ideal for adaptive streaming of 3D Gaussians. Because it needs to traverse the tree in order to build the level of detail. So for this purpose, I think there is also this new research called Lapis GS. I guess that's what it's called. It's like a progressive, excuse me. It's like a progressive layered approach for 3D Gaussians encoding. Encoding multiple level of detail into a single structure. It supports dynamic real-time adaptive streaming of different levels of detail of 3D Gaussians. It allows for adaptive rendering of large-scale 3D Gaussian. But again, so there are all kinds of these new active research projects in in achieving high quality large-scale 3D Gaussians. And I think that's what Janusz, you are very good at keeping up, right? So please keep up the good work for keeping up with all these academic research papers. Where your work is very helpful, very convenient for many researchers out there. So please keep up the good work.
No worries, I will. Thank you. Maybe as a last question to wrap it up, what is the broad vision for your tool, and also maybe for Gaussian splatting and radiance fields in general? Where do you see it in the future?
Yeah, I guess so. What we have been witnessing with 3D Gaussians of radiance fields are maybe just a tip of an iceberg that we have not seen yet. For instance, Luma AI recently kind of pivoted to the video generation AI model, but it's so their success of the Dream Machine is, I think, it can be attributed to the fact that they have this vast amounts of 3D training data, which
they mentioned it. They mentioned it like yesterday or so, because now they have camera paths and it's based on that 3D data.
Exactly. Yeah. So they have all these those 3D data that they can train the AI model with. And so also as you tweeted, I think today there is this new research project which allows you to generate 3D Gaussians from a single view image, or just a couple of images. So I would say so 3D Gaussians and radiance field, these are all still kind of initial stage at this point. Although there has been this Cambrian explosion of crazy amounts of new research projects, but I think they are very still early initial stage. So I think we're going to see more and more amazing advances in this field of technology in the future.
Awesome, yeah. So thank you for the talk. It was really fun to have you on the stream. Just to make a short announcement, next week we will have Olli Huttunen here. He's famously known for his video tutorials on YouTube about Gaussian splatting, and we are looking forward to having him here. But thank you very much that you were up with us. It was a lot of fun.
Yeah, thank you for having me.
And thanks so much, Yoshi. Appreciate it.
Yeah, thank you.
See you next